Okay, now that I've kind of walked through what a confidence interval is, let's walk through some examples on what we're actually doing with these. So in this example, September 1999 poll, there were 1,000 people randomly selected, and 230 of them stated that they knew someone capable of committing an act of violence in the workplace. So the first thing we're going to need to do with one of these is find the point estimate. So I want to know if 230 people said they knew one of these people, what percentage is that? And actually I'm going to write it as a decimal. So 230 out of 1,000, that means my point estimate, my p-hat, is 0.23, so 23% of the sample. Now I need to check that that's going to give me 5 people in each group. So 230 people knew somebody, and then I can subtract and say, well, if 230 people knew somebody, then that means 770 did not. Both of those categories have more than 5 people, so I can go ahead and calculate a confidence interval based on this. Okay, so let's say we are asked to construct a 98% confidence interval for the proportion of all adults 18 years old or older who know someone capable of committing an act of violence in the workplace. Okay, so I need to go into the calculator, and the things that it asks me for when I go into that one prop zint in stat tests is X and the confidence level. So X in this case is how many people gave the response that you're looking at. So 230 people gave the response that yes, they knew someone. N is the sample size, that was 1,000, and the confidence level is 98, so I'm going to enter that as 0.98. And then I'm going to arrow down to calculate and hit enter. And then I'm going to round to 3 significant digits. So the calculator is going to tell you 0.199 and 0.261. And you can leave it that way, or you can change it to a percentage, especially if it specifically asks for a percentage. You would want to change it to a percentage. In this case, it just says proportion, so we'll leave it the way it is, and then we'll interpret that. We need to say how confident we are. We are 98% confident that what? The proportion, the mean, what are we talking about? Well, we're talking about the proportion of who? Of all adults, because we're taking what happened in a sample and generalizing it out to the whole population. So I need to say all, of all adults, and then what were we talking about? We were talking about people who knew someone capable of committing an act of violence in the workplace, and then we'll say what it's between. So we are 98% confident that the proportion of all adults 18 years old or older who knew someone capable of committing an act of violence in the workplace in 1999, because that's the year the poll was done, that would be between 0.199 and 0.261. So I didn't say the specific thing about 1999 on the slide, but keep that in mind. This study was done in 1999, so we can really only use it to talk about the whole population in 1999. So let's try another example, and if you want to, you can pause the video and try this one on your own. We're going to calculate a 90% confidence interval, and then we're also going to calculate a 99% confidence interval so that we can compare them. So maybe you might want to try that on your own. So first thing we need to do is verify that we have enough people in the two groups to do the calculation based on this study. This time it gives me the percentage, it doesn't give me the actual number of people, so I need to calculate that. The point estimate is that in this 1995 survey, 55.2% out of the 10,847 women that they surveyed who had had a child between 90 and 93 indicated that they had breastfed the baby. So the point estimate is the 55.2%. We'll change that to a decimal. Okay, so I need to take 10,847 people and multiply it by 0.552 to figure out how many people that actually is. It does come out to a decimal. You're going to just follow your normal rounding rules. 0.5 rounds up. So we're going to round up to 5988. You do need to give a whole number to the calculator when you enter X's, so keep that in mind. So we have 5,988 women who breastfed. That's definitely more than 5, so that's not a problem. If I had 5,988, I can subtract from the total to find out that there's 4,859 who did not. also definitely more than 5. Or you can see on the slide I used the percentages to calculate both. So there's a couple different ways to do that. You can calculate both based on percentages, or you can find the first one and then just subtract from the total to find the other one. So now we're going to actually calculate the 90% confidence interval based on that information. Well, we said 5,988 women said that they breastfed, so that's your X. The N is the 10,847, which is the total from the sample. And if we're doing 90%, the confidence level is 0.90. So you go to Stat Tests, scroll all the way down to your one prop Zient, and put that information in. And then you go down to Calculate, and it should come out to 0.544 and 0.560 when we round to 3 significant digits. Okay, so that means now when I asked this question, I said find the confidence interval for the percentage. So when I interpret, I'm actually changing this to a percentage. We are 90% confident that the percentage of all women who had a child during those years and breastfed their baby is going to be somewhere between 54.4% and 56.0%. And then just for comparison purposes, let's go ahead and do a 99% confidence interval as well. So same information on the X and the N, but the confidence level changes to 0.99. And so you'll see that it changes the final answer. That confidence level actually is a little bit wider. It goes from 0.540 to 0.564. So we're 99% confident that the percentage is between 54% and 56.4%. So what's happened is that by upping the confidence level, we've made the interval wider. And that's because if we want to be more sure that the real value's in there somewhere, we need to be a little bit wider so that we have a bigger chance of catching the actual value. When you hear about these statistics on the news and in newspapers, you often hear about a margin of error, and the margin of error tells you how far the confidence interval goes in each direction from the point estimate or the sample value. So for example, let's say you have a confidence interval that goes from 0.931 to 0.949 and you're asked for the margin of error. Well, the first thing you need to find is the center of that interval. The center of the interval should actually be your p-hat. So if you already have the p-hat, then you don't need to calculate this out again. But in this case we don't. So I'm going to average those two values to find out what would be right in the middle. So I average the two and I find out that 0.94 is right smack in the middle. So that means my sample value, my point estimate, was 94%. Now I want to know how far in each direction did the confidence interval go. So you can pick either of those values. It shouldn't matter. You can take 0.949 or 0.931 and figure out how far away it is from the middle. So I just picked the upper end and subtracted from the middle, which was the 0.94 that we just found. And so I get 0.009, or if I want to move the decimal place over 2 places, I can get a 0.9% margin of error. So that says my confidence interval has a 0.9% margin of error, and there's actually, based on that, another way you can write the confidence interval. Instead of writing it in parentheses like it is up at the top with the 0.931 and the 0.949, I can say my confidence interval is, I think that the percentage is about 0.94 with a margin of error that I think it could go up or down from there up to 0.009. And I could have rewritten that in percentage format too. I could have said 94% plus or minus 0.9%. Now before you do a study, let's say that instead of reading a study, you're actually planning on doing one yourself. We need to know how many people we need to interview. And this is something that we talked about briefly at the beginning of the semester, and I said I would come back and talk about how do we know when a sample size is big enough. Well, it depends on the margin of error that you are willing to accept, and based on that and the confidence level that you want, there's an actual formula that you can use. So here's the formula, and it uses the inverse norm in the distribution menu that we used in the last chapter. So it's inverse norm of alpha over 2, and then you square it times p hat times q hat, and then you divide it all by the margin of error squared. So I've got what these letters stand for. That alpha That's what that in the inverse norm, that's an alpha, or kind of the little fish symbol. Your alpha is the opposite of your confidence level. So if you want to be 90% confident, your alpha would be 10%, and then you'll write it as a decimal. You know what p hat and q hat are already. E is the margin of error. Make sure you write that as a decimal, not as a percent. And then n is what it will tell you, and n is the number of people that need to be in your sample, and we're always going to round up. If you do have one of the newer calculators with the pop-up for inverse norm that asks for 3 values and you aren't able to only do one, just make sure that the alpha over 2 value is the area, and then you will do mean is 0 and standard deviation is 1. That's the default. So use that and you should be fine. When you're using this formula, there are two different cases that you can deal with, so we're going to do both. In this example, Spalding Corporation wants to estimate the proportion of golfers who are left-handed, so they want to do a study. And we're going to calculate the necessary sample size in two different cases. First, let's just say we want to be 98% confident that our proportion is within a margin of error of 2.5%. And then we're going to do it again under the assumption that we've actually read another study that gave us a little bit of information. So we'll walk through both of those. So here's the first scenario. We want to be 98% confident. So that means that the alpha is 2%. If we want to be 98% confident, we're willing to accept 2% uncertainty. So we're going to write that as a decimal. 1 minus 0.98 gives us 0.02 for the alpha. The margin of error is 2.5%. We're going to write that as a decimal, so move the decimal 2 to the left, 0.025. Now the p hat and the q hat in the formula we need to be careful with. That is a previous study's sample information. Well, in part A, we are not told anything about a previous study. So if you don't have a p hat or a q hat, the best thing you can do is guess that it's 50-50. So that's what we're going to use, 0.5 and 0.5. So I'll have a calculator video that walks you through entering this into your calculator, but you're going to go into the distribution menu, get inverse norm, put this information in, make sure you get the second powers in the right spots. And then you're going to go ahead, it's going to be a decimal, you're going to round up to 2165. So in this case, they would need to interview 2,165 golfers. But then in the second half of the example, we're told that there was actually a previous study done, and that study estimated that 15% of golfers were left-handed. That means we've actually got a starting point. We just need to verify it, really. So our sample probably doesn't need to be quite as large because we're really just tweaking someone else's results. So the alpha and the margin of error are still the same, but now I can use that study's 15% as my p hat, which means my q hat is the other 85%. And when you put all of that in, your result comes out a little bit different. It comes out to 1104.026, which even though it's a very, very small decimal, you're still going to round up to 1105, which is less than we got on the last slide. So having this previous information lets us interview less people. Now do notice that even though it was a tiny decimal, I rounded up, and that's because when you're planning a study, you want to have as many people as you need. So it's safer to go ahead and interview the extra person just to make sure that your study is accurate enough. That's different from when you're trying to figure out X values from studies that have already been done. Those you round normally. So it's just when you're finding the N that you always round up.